This conference will now be recorded.
Okay, so let us start now. So in the previous session, we were discussing about multi-stream transport. We were discussing about various types of devices involved in the multi-stream transport. The one is basic multi-stream transport branch device. One is multi-function multi-stream branch device. So what is branch device means? Can you tell me?
uh, like a device between source and sink,
Yeah, device between source and
splitter,
loop. It has got one incoming port and it can have multiple outgoing ports as well.
outgoing port. Okay.
Okay, so basically the basic one, when we say basic, it is only capable of display port, multi-stream transport in and transport out, the virtual channel payload routing. Basically it does the routing of the payload, as you see. Then and as an intermediary MST branch device. Then it also does DP-MST to DP-SST conversion as the last MST branch device. See, sometimes what can happen is the device that is connected at the to the branch device could be a SST one. So there you have to convert from MST to SST. So that is what we are calling as the last MST branch device. This is about a very basic MST branch device functionality. Now you can also have multi-function MST branch device, which is capable of performing one or more of the following operation. What it can do transport protocol conversion. I mean, what is mean by transport protocol? Can you tell me?
Like different protocols, HDMI, DisplayPort.
Yeah, converting one protocol to other. Let's say you may be getting information in DisplayPort, you may convert it to HDMI, or you may get convert it to some other protocol. So that is what this branch device can
Branch
do.
device can do.
And it also does video horizontal blanking expansion. It also does ignore MSA handling for adaptive sync support. Then it can do pixel encoding format conversion, one format to other format. As you see, it is doing from 444 to subsampled, this one 420 format. And it can also do display stream compression and decompression. So these are the things which we have discussed. Then virtual DP peer device with DPCD registers. See, a multi-function MST branch device or a branch sync device. See, in the this branch also can have a sync device, right? Shall enumerate those multifunction DFPs connected to the SSD devices. Basically, what it should do is it should enumerate. Can you understand? Can you tell me what do you mean by enumeration?
Mm, not sure, sir.
Basically, enumeration in any protocol means getting the entire device information. See, when you have connected a virtual DP peer device, see what is virtual DP peer device mean? The one which are plugging into the branch device, right? So that DP peer device will have the DPCD registers. What is DPCD register? The display port configuration descriptor register. So the process of getting process of reading all the DPCD registers is called as enumeration. See, what is part of enumeration, I would say. I won't say it's part of enumeration. I won't call it as it is enumeration. It's part of the enumeration. So by reading that, my this MST branch device gets to know what is the type of peer device that is connected to it. The okay, local stream links with virtual peer DPP device are equipped with DPCD registers. A virtual DP peer device with the DP output shall set MST cap bit in the this register. So there is a register in that there is a bit MST cap. Okay, I would rather say MST cap. Here sets the MST cap bit to 1 to provide accessibility of the DPCD registers of the downstream DPSST device to the DPMST source device. See, The virtual DP peer device will have one variable called as MST cap, which is part of the MSTM cap. In that, it needs to set one to make sure that my DP MST source device will be able to read that information, read the enumeration information.
Hmm.
Now, so if you see in the previous slide, we have talked about the basic MST branch device and multifunction MST branch device. So when you go to multifunction MST branch device, we discussed, right? It can have up to 5 different functions like transport protocol conversion, video horizontal blanking expansion, ignore MSA, pixel encoding, display compression. So that has been shown in this diagram. If you see, you have got a DP MST source device, and what is this device? It is a multi-function. Multi-function means whatever functions we have discussed. MST branch sync device. Can you tell me why it's called as a sync device also?
It has DPCD registers.
No, no, because it has got a local stream sync.
Okay.
Along with branching means its ability to connect with various other ports. It can also display the information. It can also sync the information.
Okay.
Now, this traffic could be targeted in any of these directions. If it is targeted for this means, it is to be displayed here itself. So you see here, we are talking about various features. One is non-multifunction MST capable DPT export, a multifunction MST capable DP++ T export, uh, then multifunction MST capable DP++ T export, HDMI T export. So various ports are there. See, this is where the protocol conversion is happening. Transport protocol conversion and pixel processing capable. So what is this device has? One MST capable DPT export, two MST capable DP++ T export, one HDMI transmit code, one local sync device. These are the various things that are part of the multifunction branch device in this case. Okay. Uh, DP++, I forgot. Actually, I read few sometime back. Let's just read once. DisplayPort plus plus. Yeah, is more flexible since they okay. That is what it can transmit any of these things actually. DisplayPort plus 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 ports can transmit DVI, HDMI, and DP signals. So DP++ means it can transmit multiple types of transport protocols. DP++ TX port 2 with the DP SST monitor connection enumerated. And see there, this is the DP SST monitor connection, right? Uh, they are talking about port 2, this one. Okay. Uh, as a virtual DP to DP peer device with virtual DPCT register. If you remember in the previous slide, we talked about, right, the enumeration by reading the DPCT registers. That is what this port will do. So this port will do the enumeration to get the complete DPCT register information. The HDMI transmit port enumerated as virtual DP to HDMI protocol converter, peer device with virtual DP. So this will enumerate it as this protocol. It will convert DP to HDMI. Now, local stream sync enumerated as virtual DP sync peer device with virtual DP-CD sync register. So this one will be enumerated directly.
Hmm.
So it is the same thing is shown here. If you see how that enumeration is being done, you can see. Uh, so here, uh, virtual DP to DP, because this is also a DP device, DP SSD device. This is a HDMI device. So they are doing virtual DP to DP peer device 2 with virtual DPCD. Here it is DP to HDMI. Here it is virtual DP output port. Just please take a look at this diagram once.
Multifunction MST branch sim device.
Okay. So I hope you have gone through it. Uh, Probably for this point of time, at this point of time, we don't need to worry so much, because only thing we need to understand is there are various types of devices that can be connected to a multifunction branch sync device. So how it enumerates and gets the information.
Yeah.
If it is DPSST device or if it is HDMI device, how does that port will behave like and get the required information?
Okay.
Next, enumeration after DP-SST monitor 1. See, once this is plugged in, enumeration after DP-SST. SST means the single stream transport. Monitor 1 is plugged into DP++ transmit port 1. See, this is also DP, right? So which one will it use? Since it is DP, it is going to use virtual DP to DP peer device. After plugging of the DPSS device, DP++ TX port 1 changed to virtual DP to DP peer device. This changed to virtual DP to DP peer device with physical DP-TX port that has got DP-SST peer device. Clear, right? Till this point?
Yes. Yes.
Next. So DP-CD register relevant to virtual DP peer device. DP-CD registers pertinent for use with virtual DP. I think, see, all that it is telling is uh, how that information will be used. Basically, we have discussed all this. We have discussed these things. Just now we have seen this part. Yeah. So there was a lot of explanation. Hence, I couldn't include that. We can just quickly go through this one. Uh, Basically, here is the list of DPCD registers. See, you see, DPCD is a big set of registers, right? Almost, you could see that in this itself, it has got almost 100, close to 300 registers, if you see.
Mm-hmm.
Not all of them are relevant for virtual DP device. There are only few things which are relevant for virtual DP peer devices. That is what is listed here. As for the remaining DPC register, multifunction MST branch device shall reply with DPC register values of its MST BU DPRX. So let us read these ones. One is DPC downstream port present. Relevant to virtual DP peer device. Let's just check one. Virtual DP peer device. Virtual DP peer device. Okay. It says whether the down facing port is present or not. So 0 means device is a virtual DP sync peer device and does not have down facing ports. Basically, in this case, the if you see this one, this would indicate that this is a device without any down facing ports, right? Because it is acting as a sync. Okay, you see, even this is a virtual DP device. This is also a virtual DP device, but in this case, the sync will give you 0 because it will device is a virtual DP sync device and does not have down facing port. Whereas if DFP present is 1, this will return 1. When you read the register number 5, bit number 0, in this, if you read register number 5, bit number 0, it is going to return 1, indicating that this is not a sync. This is a device, another type of virtual DPP device and has down facing port. This is not a sync device. It is another type of virtual DP. Now this virtual DP can be DP to DP, DP to HDMI. See, there are multiple combinations. You can see. So that is what this field indicates. Next, down facing port count. Okay, DFP count 0 for virtual DP sync peer device, 1 for other virtual DP peer devices. Next, receive port 0 capability. You see, these are all read only registers,
Yeah.
and this information will be read using the auxiliary channel. Mostly, auxiliary channel is implemented using I2C protocol. Next,
Okay.
register number 8 has receive port 0 cap 0. So what is it? Virtual DP peer devices that support the MSA horizontal blanking expansion option. I mean, whether this feature is supported or not is explained here. Virtual DPP device that support MSA blanking option shall program these registers as described. Next, port 0 cap 1. So this is capability 0, capability 1. So peer virtual DPP device that support MSA horizontal blanking expansion option. Uh, and they don't explain what is the significance of these two. Only when we go to this, we can understand what is the significance of, because the explanation is same, right?
Yeah.
Okay. Next, you remember, right? MSTM cap and MST cap. There is one register. This will tell virtual DP with the DP output shall set to this to 1. This, you remember, right? This bit was supposed to be set to 1 to for it to capable of reading the DPCD information.
Okay.
Then we have got DSC capabilities, which are explained. I think only when we go to this thing, let's say 2C, will come back. Yeah. So if you go here, DSC support. DSC, you know, right? This decompression algorithm, basically. Display stream compression, I guess, right?
This is very important for me, especially.
Yeah. So we'll discuss that part as well. So it is talking about the algorithm and the RC, various aspects related to the DSC. Uh, then things related to DSC, then okay, uh, some few things related to downstream HDMI link status reporting related registers, then few things related to DVI HDMI mode configuration and pixel processing information, then output H total H start, various details related to horizontal blanking expansion operation. Okay. Did you get a basic idea related to the virtual DPP device? What all registers are relevant?
Yes, sir.
Let's check once what all topics are there. Mm, 1, 3. Okay. Yeah. Still inside multifunction devices. Resource management. Okay. Let's try to understand more into it. Uh, I think it is related to the display stream compression. This resource management, a multifunction DP MST branch device may have multiple virtual DPP device with DSC decompression capability. Okay. This section provides policy of DSC resource management among multiple virtual DPP devices with DSC compression capability. So basically, it is talking about the various DSC capability. Capability of the DSC engine is exposed in the following registers. So there are some registers. What is the peak DSC throughput is explained as part of this register. The DSC slice capabilities are explained in this register, in this set of registers. The maximum slice width is explained in this register. So I think we can understand this register significance only if we understand the DSC algorithm. So that is something, let me plan for next session. In the tomorrow session, I will plan for DSC compression and decompression algorithm. A multifunction DP-MHD branch device with multiple virtual DP devices with the DSC capability shall expose fixed DSC capability upon connection of a sync device and persists for the duration of the connection. I mean, basically the DSC, whatever it chooses, it should be fixed. Multifunction DPMST branch device shall manage the DSC unit resource and assign DSC units to DSC engine when a port is connected based on the own policy. Okay, I think let's talk more of this when we discuss about the DSC. Okay, will revisit this part of the section. If you remember from here, from this section onwards, it is more to do with how the things get handled. I mean, if you remember in the initial section, we discussed about these things, right? Uh, how the MST source and sink works. Do you remember these diagrams? How the traffic from various streams comes and at different stages, how the different special symbols and they get multiplexed and finally they go through the DP links.
Yeah.
The following sections, starting from here, all these things 2.62 to 2.66. What I have seen is it kind of talks about individual aspects. I mean, one part will talk about this. So that is something how the payload will be distributed across the lane, multiplexing, all those things it talks about.
So
So let us
I
now
just can you just recall this payload for me? I just forgot this VC payload. What was that?
see it is the virtual channel payload, right? You see, remember in the one of the previous sessions we have discussed a virtual channel. Basically virtual channel is nothing but the one of the stream source to the sink. There is a connection established between those two, a virtual connection established, though it goes through the link, but there is a virtual connection that's established. That is what we are calling as the virtual channel.
Mm-hmm.
For example, if you remember, we were discussing about something called as, let's say you have a branch device, you have got some source devices and you have got sink devices. Let's say this source device is giving traffic to this one, this is giving this one, this is giving to this one, for example. Okay, so in this scenario, there is, if you see, all of them are going through the common link. All the traffic is going through the common link, but we are kind of establishing a connection between this and this. We are establishing a connection between this and this and this. These three green dotted things are called as virtual channels.
Okay.
The what traffic they carry is the virtual channel payload. Payload is nothing but the that main frame information or the complete frame information that you are transmitting.
Okay.
Is that clear, or you still want to talk
No,
more
no,
about it?
I can revisit it.
Yeah. So basically, each stream generates a virtual channel payload, and that will be here. Initially, it will be packed for 4 lanes. Finally, somewhere here, I think lane count adjustment happens according to the actual lane count, and that will be transmitted to the lane, the DP link. So this diagram will be exploring more in this. Okay, you see, they are talking about all the things: link timing generation, symbol sequence generation. I think you can see some of those things here. VC payload allocation, okay, uh, and the time slot counter allocation. I think you can see most of these things in this diagram. So shall we go to this section?
Yeah, we can just walk over.
Okay, sure. Uh, so let's look at the diagram only. The DPTX enables MST mode by setting this. We have seen in SST mode, mainly timing is governed by the timing of mainstream video it is transporting. The BS and BR, BS and SR symbol insertion, blanking start. Okay, stuffing symbols. Insertion interval is dictated by the main stream video. The TU of the okay. Let's So here it is talking about how that this multiplexing will happen. I mean, how do you insert? See, this is the stream source. From there, the payload. symbol generator is happening, payload is coming, and that will be multiplexed on the MTP multiplexer. And from here, MTP header symbol generator will come. SR symbol, non-SR MTP header symbol, and then you have got MTP header multiplexer. So that will be multiplexed here. I think there is a time slot counter which is used to decide which one to pick from. Okay, I think MTP counter. And now, I mean, probably we need to read this here to understand. Yeah, as you can see here, for every 63 symbols, they're sending one SR. Can you see here?
Mm.
MTP 1023.013. I think it is telling MTP probably stands for the packet multi-stream transport packet. So MTP stands for multi-stream transport packet. Okay. When you are sending MTP, they are also sending the SR symbol, MTP header symbol generator. See, for every MTP, they are sending MTP header. So SR is the header and followed by the MTP. And now, what is the size of MTP? As you could see here, it is 63. So time slot counter, so 6 bits, 64. Basically, what do you understand from this? Whenever this counter becomes 0, this information will be sent. When a MTP counter is 0, this will be sent. So that means this 63 I'm not understanding, because they're telling 1024. This 63 we need to understand the significance, but what I can see is for every 1024 symbols they're going to send one SR symbol. Now what is the significance of 63? We learned. Okay, that 63 is here. Okay. um, oh, sorry, I got it. Here there is a one multiplexer, here there is one more multiplexer. So for this multiplexer, they are going to use MTP counter becoming 0. Then they send the SR symbol. Okay. Otherwise, they send non-SR MTP header symbol. Okay. Uh, for this, they are going to send every 64 bits. Is this clear?
Yes, sir.
Okay. Uh, Next. MST link timing generation for FEC encoding and decoding. I think forward error correction, you remember, right? For every, we discussed how the FEC forward error correction, this thing happens. 500, I mean, for every 500 symbols, we send that FEC parity symbols. In case of 2 lane and 4 lane, they're talking about how frequently this will be sent. 12 FEC parity posted header for every 500 link symbols. In case of 2 lane and 4 lane, 6 FEC parity posted header for 250 link symbols. So if you see, they would have explained the same concept. Uh, I I don't see the multiplexer diagram here, but it is one of the things they will send if in case of FEC is enabled. So the concept of FEC is applicable for MST as well.
Okay.
Next, the symbol sequence mapping into payload. The payload bandwidth manager of each DPTX in the path from DP source to target sync device allocates time slot within MTP to a virtual channel payload to establish the virtual channel for transporting a stream. See, if you see one DP source, DP sync, I may have to generate multiple streams. So as when I want to send multiple streams, the DPTX establishes a allocates the time slot. See, given this time slot, what I'm sending, one part of the time slot need to be allotted to one stream. Another part of the time slot I need to allot for another stream. So that is what it is, allocating time slot within MTP to a VC payload to establish the virtual channel for transporting a stream. When no time slot is allotted for any VC payload, all 63 non-MTPH time slots are filled with data all 0, 0. If there is nothing to transmit, then it will fill with all zeros.
Zeros.
It's like idle data.